we need to evaluate the data networks. So from the evaluation of this network, we need to have information about the connectivity and protocols that I said in the previous slides. Actually, connectivity describes the study and practice of how to interconnect these devices so that they work together seamlessly. Another one issue that we need to know about the evolution of data networks is knowing about the protocols. Protocols are rules governing operations. The protocols which is used in the internet is called internet protocols, IP. IP is internet protocols that allow computers to communicate with each other. These rules allow the computers to make a connections with together, to send and transmit data from one place to the another place. Now, we have two different main methods for transmitting data from a source to destination. The first one is packet switching. At this model, as you see here, suppose that this is our network and I want to send data from A point to the B point, and my data is this. What can we do? How can we transmit with them using the method the packet switching? In this method, I break up the complete data file into the small packets and packets. So I use these packets with different ways. At the end, I combine all of the received data from the different ways of network. This kind of method for transmitting data is called packet switching. Packet switching. The second one is circuit switching. Actually, in early telephone days, a telephone connections was made by an operator that physically connecting a wire from your phone to the other person that being called. As you see here, at this section, for connecting between this section for transmitting data, physically these switches in a suitable way is connected to each other to make a connection between two phones. This type of transmitting the data is also called circuit switching. But today, in the digital age, we used from the packet switching for sending the information. Now, we talked about the internet protocol. Generally, we have two most common protocols for transferring data. Okay, we said that for transferring transferring data between the components of a network, we need to have and know Internet protocols. One of the most common protocol is transmission control protocol / internet protocol, which is called TCP/IP. TCP/IP. The term TCP indicates the structure of data packets. Indicate the structure of data packet. Indicate the structure of data packet. TCP. And IP specifies the addressing and data packet size to make actually communication between the computers. Addressing data packet. So, as you saw, we broke up the data through the network and transmit the data packets in different ways. So, for integrity at the data receiver, we have to detect the error. We talked about the detecting the error in the previous chapter. Now, if no error is detected at the destination, if no error is detected, the destination transmit a short acknowledgement data to the source. Actually, send the pulse, which is called acknowledgement data packet, to the source. If the source does not receive any acknowledgement data packet signal within a specific time delay, the source assumes that the data packet was lost and retransmit the data packet. Look at here. This is my data packet that I received in the destination, for example. This is the data packet 1. Data packet 2, data packet 3. If I receive, this is a destination. If I receive the data packet and I found that this data packet has no error, I send at the end of this data packet, I send an acknowledgement data packet, acknowledgement pulse, which is called ACK, to the source, from destination to the source. And source found that the transmitted data was correct because the source received acknowledgement data packet from the destination. Again, the destination investigate this data packet. If there is not any error at the end of this data packet, send the acknowledgement pulse to the source, and also at the third data packet, send the ACK. In this case, the source found that the transmitted data was received correctly. Okay. Now, if destination detects an error in a data packet, the destination sends a short not acknowledged data packet to the source and requests to retransmit the data. So sending acknowledged data packets and not acknowledged data packets slow the data transfer rate, but data are transferred successfully. This method is used for web surfing, downloading documents on the internet. The second one is Universal Datagram Protocol/Internet Protocol, UDP/IP. At this method, we transmit data from source to destination with minimal delay by eliminating the retransmission of erroneous packets. We don't send the acknowledgement and not acknowledgement data packet from the destination to the source. This method is used for applications that cover the telephone calls over the internet or video streaming and so on. If we use from TCP/IP method for applications that produce internet video or a voice call, sending not acknowledgement pulse and acknowledge pulse will involve time delay and cause annoying pause in the audio or video playback. Therefore, for eliminating these pauses, we use UDP/IP method. In this method, we need to accommodate received data packet that contain error. So how can we do that? How can we correct the error? One approach in this case is replacing an erroneous data packet with the previous good data packet. Or another way is using empty data packet or average data packet. We talked about the IP. We said IP protocol, IP address. What is this IP? Actually, we can say that IP moves data between computer systems. Using the IP address, we move the data between computer systems. IP address is a path that if we say the IP address of this computer is this, the data transmitted to that address. Generally, we have two addressing schemes for TCP/IP. IP version 4, IP version 6. IP version 4, IP version 6. In the IP version 4, as you see here, we use 32-bit number and represent it as a 4-part decimal number. Each part is represented by 8 bits or 1 bit, which is called octet. 1 byte is called octet. Each decimal value is in the range of 0 up to 2055 because I have 8 bits. It means that I can have 286 different number. So it means that at each part I can use a number between 0 up to 2055. So the first three numbers or the first three bytes contain the network address. This is the address of network, and the last byte is for host address. It means that we assign a number for each computer. This is the address of your computer, and this is the address of network that this computer, or generally this host, is connected to this computer. This is the general form of representing IP version 4. And we have the IP version 6. This type of IP version is used with 128-bit number. We use 8 sets of 4 hexadecimal digits, and each part is separated by columns, as you see here in the figure. 8 part, 4-bit 8 part, represented in the hexadecimal form.